Alright, everybody, I think we are back on. How's everybody doing out there? I'm doing pretty good. So we've got our stream going. This is a continuation from yesterday. Today we're going to be hopping straight back in to editing the episode that's going to be going up tomorrow. Should be good. We'll see. Yeah, I guess what can I tell you? Oops. One moment. All right. What I can tell you is we're just going to get straight back in. There's no real magic to this. It's just going to be going shot by shot, making sure that we're hitting all of the parts that we need. And it's going to be a slow grind, but slowly but surely we will get through this entire video because we need to for tomorrow. All right, let's hop over to Premiere and take a look at where we're at. So I just added the last effect that we did for the night last night, which was where the brain has a cushion and it sort of gets sloshed around at the end there. That was a nice effect. I liked how that looked. No real need to go back. We're just going to move forward onto the next effect. Let me turn up my volume here so I can hear what's going on.
It also plays a role in immune function and, we think, cleaning up waste.
Okay. No real, I mean, there's some content, but it's all spoken. I'm going to zoom in there. Get a nice close-up. There we go. Is that too similar to the last shot? It's not. She's centered. Maybe we can zoom in a little bit more. There we go. What did you think?
It also plays a role in immune function and, we think, cleaning up waste.
Now we missed her little hand motion down there. Her little, she like points a finger, which I sort of like. So we're going to try and keep that. Yeah, it's not a bad transition.
It also plays a role in immune function and, we think, cleaning up waste.
Cool. All right, what is this next section?
The brain produces a lot of CSF every day, about half a liter, which is about this much. And we're pretty sure that it filters out into the rest of the body. But scientists are still working on figuring out how exactly CSF is produced and where it eventually goes.
So we're going to do a cut there because there's a little breath.
To the body.
Right there. And right there. Just to keep it snappy. We're also going to, it'll allow us to move the shot a little bit. So actually, because this shot I moved in, you can see, we see this little container come in. That's my hand right in the corner. Oh yeah, my cameo. Okay, but I do want it to be this zoomed in. Yeah, because we want to be able to see well enough how much liquid is inside that container. I even move her down slightly. There we go. So that means that we have to change this one. And we have two options. We can go close or we can go far. We're going to go close. Oops. Try and keep this centered. Let's try that.
It also plays a role in immune function and, we think, cleaning up waste. The brain produces a lot of CSF every day, about half a liter.
That's good. Okay. And let's just check this transition.
Filters out into the rest of the body. But scientists are still working on figuring out how exactly CSF is produced and where it eventually goes.
She sort of stumbles on figuring out, but that's okay. We can't always be perfect, right? Figuring out. All right, we're gonna zoom in, or rather zoom out. Right about there. Let's see how that looks.
Rest of the body. But scientists are still working on figuring out how exactly CSF is produced and where it eventually goes.
So that could actually, we could do some text there. Now that I'm thinking about it. We don't need to go super crazy. But let's drop this into After Effects. Let me bring you over there. And it's just going to be super simple. We're going to be... what are the two things that she says? No, I forgot.
But scientists are still working on...
So how it's produced and where it comes from. Where it eventually goes. Okay. How it's produced, where it eventually goes. How can we distill that down? I mean, how produced. Scale that way down. That'll work more or less. It's not the best language use, but it's good enough for our functions. How produced. Let's make the how a lot bigger. Or you know what? I'm actually going to go opposite here. Let's make the produced smaller because the text is getting a little out of hand, a little too large. How produced. And I don't, usually I try and scale it so that it's more or less within a box. In this case, since there's a question mark, let's actually grab the text. I don't mind having the question mark hanging off, as long as the stuff underneath it isn't. How produced. So the question mark's sort of outside the box, but that's okay. Like so. We can even... yeah, I think that's fine. Okay. So now we'll take that, move it on over. How produced. Let's add a drop shadow on that. And then where it eventually goes, is that what she says?
And where it eventually goes.
Mm-hmm. Why don't we, let's do this. Let's pull in some hip language for the kids, right? How produce, where go. Alright, now you can see that we really just crack ourselves up while we're editing. It's just, it's a constant joy. Alright, where go? We're going to position that as well. And that's more or less in the same spot. I always like to orient it a little bit higher because if there's subtitles or anything down below, you don't want this text to get chopped off. I'm gonna have the go be a little bit closer though. There we go. Where go? So let's copy the drop shadow from the other. There we go. Now I could put a green thing on this side as well. I'm thinking about it because this line of the bookshelf is really bothering me. It's crooked, but it's really just the perspective. Well, it's also our floors. I think our floors are crooked in this room, but this line is okay. This line is more or less straight, but this one looks way off. So that line sort of tilts that way. This one tilts that way, which causes a lot of problems in terms of orienting the video. What do you think? Do we want that green part? Feel free to just type in the chat. I'm always looking for feedback. As I'm going along, I'll be putting in your suggestions. It was nice actually last night when I was doing this. I was, you know, editing obviously, and was getting some good suggestions from folks. Okay. Let's do it. We can see if it works. Great. If it doesn't, then we can delete it. Let's just take a look here. Grab this green solid because this is on the correct side. Yeah. You know, sometimes you just gotta reuse stuff that you've already used before. If you know that it works, why not? Okay. No, I just don't think it needs the green. Alright, I've made the decision. It's, you know, we reserve the green for like information. However, this line really is bothering me because you can see it line up with the text. So even though we don't do this in any of the other clips, we're just gonna change it about 1%. And that helps a lot, actually. Maybe 1.2. Ooh, now it's too far. All right, just 1. There we go. All right, now we got to animate these. Add our script on there. That makes it come on nicely.
The scientists are still working on.
All right, so she's saying how. So come on right there. Boom. Turn on the motion blur for these guys. How it's produced. And where. Right there. There's the where. I'm gonna put it right there. Okay, that should line up nicely now.
Figuring out how exactly
CSF is produced. And where it eventually goes.
Okay, let's watch that
figuring
again.
out how exactly CSF is produced and where it eventually goes.
That's not bad. Yeah, I don't mind that. I'll center the where though. Let's move that right about there. Centered underneath the how. Good. Okay. Next, let's bring you back over to Premiere. Okay, so we've got that new effect in there. Let's listen to the next part. Play.
In 2012, Danish scientist Micah and her lab coined the term glymphatic system when they published an exciting study that clarified how CSF could be helping the brain to clear out waste, and maybe giving a hint at why sleep is so important for our health.
Alright, so this is where she introduces officially the glymphatic system, which is what the video is about. 2 minutes in, we had to set up a little bit about the lymphatic system to sort of get an idea about what we're talking about. Let's listen to that clip one more time. Come on.
In 2012, Danish scientist Micah and her lab coined the term glymphatic system when they published an exciting study that clarified how CSF could be helping the brain to clear out waste, and maybe giving a hint at why sleep is so important for our health.
Okay, so that I could cut that. We'll see what ends up happening. So she mentions the scientist's name. She mentions glymphatic system. And later talks about sleep. So let me just get the name of that person. I'm gonna see if I can find a picture of them. And then maybe we can use that in the video. I always like to acknowledge the scientist with an actual photo. In 2012, Danish scientist Making Nadergaard. Alright, give me 1 second, folks. I'm going to try and... oh yeah, there's plenty of pictures. Okay. Pull out a large photo, if possible. That is a small photo that has been blown up. I know you can't see what I'm looking at right now, but I am currently just trying to find a photo that we can use of this woman. Okay, let's go a little bit smaller. Okay, these are nice. That one's not bad. That one's not bad. Okay. Let's see which one's larger. Let's see. You know, these are really small photos. We need like a repository of photos of scientists. Doesn't matter like if they're super famous or not, but just like enough photos so that people's accomplishments can sort of be acknowledged, you know? Oh, that's a great photo. All right, I found the perfect one. Okay. Let me save this in my foil. Lymphatic system. Making Nadergaard. Okay. I'm going to be editing this a little bit in Photoshop, so let me open that up and I can bring you into that. Just give me 1 moment to get things fired up. Go. Open with Photoshop. Let's see if this works. There we go. Okay. 1 moment. Let me get you into this. Oops. 1 moment here. Just got to import the image so you can see what I'm looking at. Okay, there we go. Okay. Alright, here we go. Sorry, just had to get that set up so you could see what I'm actually working with. Let me just check over on the chat here. See who's hanging out. Vitor. I hope that I'm pronouncing that correctly. Thanks for hanging out. So we're just going to be going over some edits on Dr. Niedergaard's photo. So what I like to do, because if I were to just drop this straight into our comp, it would look kind of ugly because you've got these edges, these hard edges of this background that really doesn't add anything. And it also just takes up a lot of space. So what I like to do is just cut out the person while also incorporating the background if needed, because she's like leaning up against something, so it would look a little strange if there was nothing there. So what I'm going to do is grab my tool here. Let's bring this way up. Okay, that's good enough. What I think I'm going to do is I'm going to grab her and then this part, this edge over here, and then what we'll do is we'll put her in the corner. We'll put her image in the corner so that it just sort of flows. So let's grab all of this, all this business, the whole railing, and that, and then let's get her hair. There we go. That's not bad. Okay. Oops. All right. It seems like that's a fairly basic grab. Let's get a little bit more hair there. I don't want to go too far out because even though there are nice wisps of hair there, see, and it'll grab that background. We just really don't want that brick. Luckily, it sort of blends in with her hair, so the mask should come out okay. Okay. We might not take that. Sorry, I'm getting a little caught up in the finer details. All right, let's see what that looks like. And let's sort of mess with the mask. So, okay, so we're missing something right here. Obviously the hair looks a little strange on the outer edge, so we might mess with that a little bit. And while this is peculiar, I might only eliminate this middle part. Alright, so let's capture that polka dot. Let's bring in the mask slightly on the outer edge of the hair. Right up here, around here. Oop, nope, too far. And then we're going to zoom in, bring this way down. And we're going to just cut that out right there. Oops, wrong direction. Yeah, that's not bad. Great. Okay, let's try that one more time. Looks a little cleaner. The hair looks weird right here. So let's quickly fix that. Gotta have a nice smooth transition. Don't want it to look like it's just sort of cut out. I want it to look natural. That's not bad. Yeah, much better. And then what we're gonna do is we're gonna, oh, is that something? Okay, sorry. Perfect. Now we're going to smooth out these edges, because as you can see, it's really just jagged, like along the hair and on the shirt. Like you have all these jagged, sort of pixelated areas, so we're going to smooth that way out. There's disadvantages to smoothing, which are that by smoothing you round edges as well. So like down here in the corner, right here, you see that rounding. If there's no smoothing, then they sort of disappear. I'm okay with a little bit of that because I can go in and remove that later on. I don't want to go too overboard. Also the edges, like here, get a little rounded. So let's go... Let's go to 40s. Yeah, that seems alright. And then what we're going to do is you can still see a little bit of that like reddish brick tinge on the outside. So we're going to shift the edge in. There we go. That'll just sort of eliminate that color. Not bad. Okay, that's looking decent. I don't want to feather the edge. I don't need more contrast. I think this is going to be good enough. So we'll save that. Oh wait, I gotta, what am I doing? We're gonna copy paste, remove the background, and then we're gonna save it. And we'll save it again. I always save one Photoshop image and then one PNG. PNGs are just a little bit faster to work with, even though you can sort of do live editing. This isn't something that I anticipate editing live. So, all right, let's go back to Premiere real quick, and we're going to grab this clip and drop that into After Effects. So let's go back over to After Effects. And now we have the clip, and we're gonna line this up with, we'll drop the image in when she mentions her name.
In 2012, Dana...
Alright, there it is. So let's drop her right in. Hello! Okay. It's great to work with large images because you can scale them so easily. We don't even need her to be that large, but it's nice to have the flexibility. Okay, so Allie, I think, is a little bit far away. Also, we'll probably want her, I think this is where we're presenting some information, so we're going to have a green side on this one because she's given a lot of information. Let's just hear the audio.
In 2012, Danish scientist Micah and her lab coined the term glymphatic system when they published an exciting study that clarified how CSF could be helping the brain to clear out waste, and maybe giving a hint at why sleep is so important for our health.
Okay, so there's not too much information, but the points that we really want to hit are the glymphatic system. We don't need to emphasize 2012. Later on she mentions sleep. We might just have the glymphatic system and then some Z's going over the top to sort of indicate sleep. Yeah, I like that. So we're going to keep Dr. Nedergaard up front and center. Allie's going to zoom in slightly. There we go. Let's just make sure that that doesn't replicate an earlier shot. No. Okay, good. And this time, instead of a green side from left or right, we're actually going to have it come up from the bottom. So, sort of like we did before, we're going to create a new solid. We're going to scale it up, move it down, and then we're going to mask it. The reason that we mask it is that we can get a nice feather on it. So we're going to look at that edge and just feather it out slightly. There we go. Nice and soft. And then Dr. Nedergaard doesn't have to be so pronounced. Well, yeah, that seems about right. And we're going to move her down. That's pretty good. That's a pretty good spot right there. Look at that. So she sort of peeks over the edge. Let's just take a look at the edge here. Yeah, that's nice. We'll give her a drop shadow too. Why does that look weird? I guess because it's such a large image, it just doesn't. Yeah, not crazy about that, but we'll keep working with it. And then she mentions glymphatic system. We'll scale that way down. We'll put a drop shadow on that. And we'll position it. So we have two options. We can center it, or we can move it off to the side. So if we move it off to the side, then we'll want to scale it down so that it's not overlapping with Dr. Nadergaard. If we want it centered, then maybe we want to make it even larger so that it's right visible, really visible right there. I don't know what would be the best option here. It's sort of up to you in terms of what you think might be best. I always tend towards clarity in terms of and readability. So what I might do is scale this down. Like that. Give Dr. Nadergaard her space. Or large. I don't know. I can't decide. Any comments? Any suggestions? Large or small? Overlap or no overlap? Well, I'll tell you what. Let's keep the overlap for now. And then we can change it later if we want to. Luckily, it scales from the edge. So we're going to do this. We're going to move it down so that's more centered. And then we'll animate this. Great. And we also need to animate Dr. Nadergaard. She's going to come in from the side. There we go. In 2012, and then she should come in right there. Excuse me. All right. And then let's go forward. She's going to mention the glymphatic system.
Nadergaard and her leg and
Wait.
in 2012, Danish scientists making.
Oh, there she mentions her. Okay. Micah Nadergaard.
Scientists Micah Nadergaard and her lab coined the term so do we also have it come up during glymphatic system? I think so. All right. Turn on motion blur there. The term glymphatic system.
We'll have it come up during glymph.
The term glymphatic system when they published an exciting.
Okay, great. So that animates on. Dr. Nadergaard's right there. Sorry. Okay. We also need the green solid to animate on. Good stuff. And we'll have that come right before Dr. Nadergaard.
British scientists Micah Nadergaard and her
coined the term
glymphatic system
Perfect. Oops. Good stuff. So now we just want to possibly do something about when she mentions sleep.
When they publish an exciting,
That's just for the sake of making it easier. We're gonna just listen to the audio.
An exciting study that clarified how CSF could be helping the brain to clear out waste, and maybe giving a hint at why sleep is so important for our health. The brain to clear out waste. CSF could be helping the brain to clear out waste.
And why sleep may be so important for our health. Okay, so clearing out waste and health. With the waste, I feel like I could do a sound effect of like bottles being put in the trash or something like that. With the sleep part, I do like the idea of having some Z's or something floating up.
And maybe giving a hint at why sleep.
So there's sleep. She says sleep. Okay. So let's get your old-fashioned Z. Let's find a font that works a little bit better, that makes it look sleepier. Because while I love using our font, I don't think it screams sleep. But we want something sans serif. Yeah. What, you're not going to do it for me now? Come on. I selected one. This guy. Come on now. Why are you not working for me? Huh, that's weird. Okay, let's try a different text, I guess. That's not bad, noteworthy. Alright, let's keep moving. Veranda. I want something a little softer. Let's go with noteworthy. There it is. And we'll give it a nice blue twinge, because that's sleepy, right? We sort of want it to fit the green that we've got going. Yeah, it's maybe like a darker blue. Midnight blue. Let's try that out. Okay, so we've got our Z, and we want it to float up from sort of this corner, I think, over the glymphatic system text. So we'll scale it down. Position low. And I sort of want it to just bounce a little bit as it goes. We'll want to mess with the rotation too. Have it rotate from the middle rather than from that edge. There we go. So let's do the positioning first. Have it go up here. We can always mess with. Oh, come on. Oh, that's why. We can always mess with the scale and all that stuff. I sort of want it to bend, like it floats away at the end, you know? Alright. Like so. Alright. So we've got a...
Why sleep is so important for our health.
Okay, so we've got the basics.
Why sleep is so important.
It can even take a little bit longer to do that. And then I think I want to mess with the rotation here. So we're gonna do this, do this. I just sort of want it to bounce back and forth. Let's see what that looks like.
Why sleep is so important for our health.
Nope. Let's try that out.
Why sleep is so important for our health.
No, that doesn't really work. You know what I'm talking about? Like I want it to just sort of like as it's moving. It might have to affect the position too later on, but right now I'm just a little worried about the rotation. Okay, let's see. Hello, new people. We got Willem and I'm really bad at names, guys. Feder, or is it Fedor? I'm guessing Feder. Still editing, still at it. Thanks for joining, coming back. Let's see what we can do. So we're gonna remove that effect and just freehand it. See if we can get this going.
Why sleep is so important for our health.
Ugh, I hate that. Let's try easy ease.
Why sleep is so important for our health.
Nope, hate that too. That's horrible. Okay, let's try that.
Why sleep is so important for. Why sleep is so important for our health. 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 In 2000.
It's gotta be slow, you know? It's gotta be a nice, slow.
Getting a hint at why sleep is
so important for our health.
And then it's gonna disappear at the end.
Why sleep is so important for our health.
It's not great. I think what I want to do. Let's do this. Let's do some positioning at the spots where the rotation happens. And I think I just want to slow it down slightly at those spots. Not a ton, but ever so slightly. Wait, why did it do both? No. I just want to edit the position. We're just going to move these a little closer.
Be giving a hint at why sleep is so important for our health.
See, it's moving. I actually don't like that. Oh, that's because I did it opposite. Oops. Sorry, folks, bear with me.
Be giving a hint at why sleep is so important for our health.
Nope, that's horrible. That's really bad. All right. Do that.
Why sleep is so important for our health. In 2000, giving a hint at why sleep is so important for our health.
Nope, I just don't like it. All right, we're gonna delete that. Let's see what this
Be giving
looks
a
like.
hint at why sleep is so important for our health.
I think the rotation needs to be a little more subtle. It's a little intense. Yeah, see that goes from 33% to 0. Let's do one of these. Let's try that.
Be giving a hint at why sleep is so important for our health. Giving a hint at why sleep is so important.
I just don't understand why it pitches so much right there.
Giving a hint at why sleep is so important.
I think it's got to come from a very sideways angle.
Giving a hint at why sleep is so important.
There we go. Let's see what that looks
Giving
like.
a hint at why sleep is so important for our health.
Nope. All right. So let's just try deleting that.
Be giving a hint at why sleep is so
important.
Sometimes it's the simple things. You just gotta go with the simplest. Oop, let's not do that.
Giving a hint at why sleep is so important for our health. In 2000.
Yep, I think that's
Be giving a
what we
hint
gotta
at
do.
why sleep is so important for our health. In 2000.
Ugh. You know, I try to make it complicated, and it just turns out that you don't need that. So from right here, we'll start fading out the opacity down to 0.
For our health.
Okay, that
Giving a
works.
hint at why sleep is.
And we can also fade that in from 0.
Hint at why sleep is. Hint at why sleep is so. Hint at why sleep. Hint at why sleep is so important for our health.
Okay, we're going to scale this way down. And then we're going to duplicate it. Before we do that, let me just clean this. Okay.
At why sleep is so important for our health.
All right. Move it back a little bit more. We need some space between these. And we're also going to position them slightly differently so that they're not all following on the same track. There. Let's see what that looks like.
At why sleep is so important for our health.
Okay, that one doesn't have to be so far off. There.
At why sleep is so important for our health. In 2000.
That looks pretty good.
At why sleep is so important for our health. In 2000. Why sleep is so important.
All right, let's take a look at it in the grand scheme of things. I'm not convinced by the color.
Hint at why sleep is so important for our health. In 2000.
Also, do those look like 2s? Whatever. All right. Yeah, the color still bothers me because it doesn't really match the green. Let me just grab this color and see if I can find a better blue. Give me 1 second. Oh, Fedor. Fedor. Cool. All right, sorry. Let's find a color palette. What I'll use sometimes is just I'll go online and enter in a color that I have and try and find a palette that works with it, because usually it'll offer me some colors that are similar. So this looks pretty good. So let's try changing this color. I found it's a more greenish blue, but it's supposed to fit with this green color. And let's just edit the blue. Oh, I can't see it anymore. Yeah, I'm fine with that. Yeah, I mean it doesn't stand out, which I guess is a good thing. It sort of blends in, and so let's just take a look at that at the end.
A hint at why sleep is so important for
For health.
Yeah, I like that. It's subtle. All right, good. Okay, enough with that. Let's move on to the next scene. So back here in Premiere, we've now incorporated this new animation.
And, most exciting of all, it involves astrocytes.
It involves astrocytes. Do we want to put anything there? Do we want to put an astrocyte? Just have it fly on or pop on? Like an astrocyte. Why not? Her name is Allie Astrocyte. We should put an astrocyte on there. People should know. People need to know about them astrocytes. That astrocyte. Alright. I'm going to bring in, let's switch it back over to After Effects. This one will be like 2 seconds. And we'll drop in our astrocyte. We'll put a drop shadow on it. Oh, which reminds me, we have to go back to our other comp. And for the Z's, they need drop shadows too. So we'll do that. Okay, see, now they're a little more pronounced, which I like. Yeah, that's nice. Okay. And, most exciting of all, it involves astrocytes.
And, most exciting.
It involves astrocytes. What do I want to do here? Okay.
And, most exciting of all,
Scale it down slightly.
it involves astrocytes.
Move her onto the side and then have an astrocyte pop up over there. Sure. Yeah, we're gonna have this pop up. Okay, so this is gonna pop up from 0. Scaling. So as you can see, it sort of goes upside down. We want to delete it right there. Boop.
Most exciting of all, it involves
At its largest right there.
it involves astrocytes. It involves astrocytes.
Yeah, that's
It
good.
involves astrocytes.
We can make this astrocyte maybe even a little larger.
It involves astrocytes.
Too big. Oops. Sure. All right, let's move back over to Premiere and keep moving.
Dr. Niedergard's graduate student, Dr. Jeffrey Iliff, was trying to figure out how the brain clears out debris if it's not connected to the lymphatic system.
All right, so now we're getting to the central tenet. We have this concept of CSF as the thing that clears out the brain when you're sleeping. But he's saying, how can it do that when it's not connected to the lymphatic system, which is what cleans out the rest of the body? Well, first off, let's see if we can get a picture of this guy. Dr. Niedergard's graduate student, Jeffrey Iliff. Let's find a picture of this guy. Oh yeah, totally. Let's see if we can find a large picture of him. And I'm saving these. I think the sometimes these pictures are Creative Commons, sometimes they're not. If they aren't, then I always make sure to save what they look like, or sorry, save their address so that we can link to them as sources. That's not bad. It's not a bad picture. That's not a bad picture either. So do we want him talking on a stage, or do we want him looking right at the camera? They say that when you are not looking directly at the camera, you appear more attractive. Well, let's go with the one that he's not looking at the camera then. Jeffrey Iliff. And once again, we're going to, sorry, I know that you can't see what I'm looking at. We're going to hop on over to Photoshop. There we go. And I'm going to open up that picture that we just grabbed, if I can find it. Oh, it's back where I was. There we go. Okay, so there's our picture of Jeffrey Iliff. And just like we did with Dr. Niedergard, we're going to start grabbing his outline. Oops. Okay, that's going to be a little difficult with that dark background to grab just him, but I think we can do it. Alright, let's zoom in, make sure that we're getting all the edges and none of that background business. That doesn't look bad so far. That actually looks pretty dang good. Yeah, that's fine. Good, okay. Now let's clean up the edges. See what it looks like. Well, that is not a bad start, I'll tell you. We're going to smooth it out without deteriorating the edges too much, like so. We'll shift the edge in slightly, just because I like to do that to eliminate any softness, prevent any bleed. Okay, I think that looks good. And we've got our image. So we'll save that. And we'll save it as a PNG. And we've got ourselves the next file. So let's hop back over to After Effects. Oh, nope. Let's go to Premiere. I gotta drop these two clips. They're separated because while we're recording, every 5 minutes it stops the clip and then goes to the next clip. So there's a little bit of a separation there, but it's not that big of a deal. You can't notice it in the video. Alright, so we've got our clip. We're going to drop in Jeffrey right there. And he can be on either side because he doesn't have an edge to him. So he can be over here, he can be over here. If we want to be consistent, we can keep him over here. We'll figure it out though. We'll see what feels right once we go through this video. Let's listen to the audio again.
Dr. Niedergard's graduate student. Dr. Jeffrey
Alright, let's listen to that again.
Dr. Niedergard's graduate student, Dr. Jeffrey Iliff, was trying to figure out how the brain clears out debris if it's not connected to the lymphatic system.
So it's really just him. How the brain clears out debris. It's not connected to the lymphatic system. So we might put a little question mark over his head or something like that. But other than that, it's really just getting him on the screen, which we're halfway there. Okay. So let's do the animation for him coming on. I'm going to keep him in the same corner just for consistency's sake.
Dr. Niedergard's graduate student, Dr.
Okay.
Student, Dr. Jeffrey Iliff.
Come on, right there where she says Jeffrey. Jeffrey.
Dr. Jeffrey Iliff was trying to figure.
And I think we want to change her perspective. She's a little far away from the camera. Yeah, we don't have to zoom her in too much, but just a little bit. Also position her lower and off to the side ever so slightly. Yeah, that's not bad.
Dr. Jeffrey Iliff was
trying to figure out how the
how the brain clears out debris if it's not connected to the lymphatic system. So we might just put a question mark over his head. You could do like a little speech bubble, I guess, or a thought bubble. Thinking about it. How does it clear out debris if it's not connected to the lymphatic system? We don't need to demonstrate that well. We might just put in a bubble though. Thought bubble. I know I've got a thought bubble somewhere. One moment. There we go. Here's one. Yeah, let's pull this guy in. Let's see what happens. So we've got this thought bubble. And he's going to be thinking. We're going to flip this though. There we go. That way it's more central. We'll rotate it ever so slightly. And what we're going to do is we're going to separate these out anyway, so we can sort of position this wherever we want. I might actually undo the rotation. Yeah, just for now. So duplicate that. No, before duplicating, let's change the color, because that is an ugly color. I also don't particularly like the stroke on the outside. There's like a black stroke. We're just going to totally eliminate that. There we go. And let's pick a color. How about, it's got to be something slightly light. Blue's always good. Blue's just a good color. We could do a poppier green. We could do a yellow. We could do an orange. Yellow's not bad. Let's do a bright yellow. Yeah, I like that. Okay, now we can duplicate it. And we're going to mask each one of these. Okay. And last but not least, okay. So now you can see these are all separated. The reason that we're doing that is we can have fun with each of the individual bubbles now. So we'll have them scale from the middle of each one. And I can also now move these around independently. So this guy can be here, and then this one can be there, and this one can be wherever I want. He's really thinking. He's just like, what am I gonna do? How do I solve this problem? Okay. There we go. That looks nicer. Let's do a quick animation on it. Oops, on the scale. From 0. And then we're going to, oops, I don't want that. Move these so that they're all in a row.
Jeffrey Iliff was trying to...
Oh, I forgot to animate those. Give them their nice bounce. And we're going to move them over here.
Jeffrey Iliff was trying to figure out how...
Good stuff. Turn on the...
Iliff was trying to figure out... Iliff was trying to figure out how the brain clears out debris.
And then we'll put our question mark right in the middle. Question mark. Scale that down. It's going to be white. It's going to have a drop shadow on it. Good stuff. And we'll center that right there. I'm not crazy about the script, about the font. We can go back to our traditional one, which I think I'm going to do. Yeah, that just seems right. Scientific looking. Okay, so he's asking the question, but we're also going to animate his question mark. Good stuff. No, why do you do that? Okay, let me just do a little cleaning here. Gotta keep your comps organized. If you ever want to come back to it and it's a total mess, that's just too bad.
Jeffrey Iliff was trying to figure out how the brain clears out debris if it's not connected.
Whoops. Let's have the question mark Scale from the middle, huh? There we go.
Debris if it's not connected to the.
If it's not, I sort of want the question mark to pop up right there. Boop. And we'll turn on the.
Out debris if it's not connected to the lymphatic. Debris if it's not connected to the lymphatic system. Dr.
That's not bad. Okay. Simple, straightforward. Let's move on. Go back over to Premiere here. And now we can see that that effect has come over. Hey! Thanks for joining. I'm seeing some more people coming in. Alright. So let's keep moving, huh?
So, he decided to inject dye into the CSF of mice to track the flow of the fluid.
Okay. Inject dye into the CSF of mice to track the flow of the fluid. Really quick, I'm going to see if I can find something. You know, I don't think I'm going to put any animations on that. We don't need it on every single thing. It's such a short clip. It just would be a throwaway.
The fluid into the CSF of mice.
Also, like, not exactly the most pleasant thing to visualize is injecting mice with a needle. So, alright, we'll just keep moving.
Oh, he decided to inject dye into the CSF of mice to track the flow of the fluid. Using a technique called two-photon microscopy, a high-tech kind of microscope that lets researchers get a clearer look at deeper tissue levels, they found that the CSF actually flows around the blood vessels of the brain.
Okay, so she talks about two-photon microscopy, which I think there's some really cool images, if I'm not mistaken, using that stuff. Two-photon microscopy. Let's see if we can find. Yeah. See, this is the kind of stuff that Allie does. Two-photon microscopy. Let's find some images, huh? Yeah, that's some cool stuff right there. Alright, let's see if we can find some Creative Commons stuff. One moment. I know you can't see what I'm working on, so I'll just show you my beautiful face while I'm working. Okay, it won't take me that long. I'm just see if I can find something. Two-photon microscopy. That's a cool one. Okay. Let's try this guy out. So what I'm doing is just finding some photos of two-photon microscopy that we can use to just show what this is possible, like what's possible with two-photon microscopy, what resolution you can get, what you can actually see with two-photon microscopy. That's a cool image. Sorry, eventually you will see these. Alright, so we've got a few pictures that are very colorful that can show you what exactly two-photon microscopy can do. Let's just make sure that this was actually done with two-photon microscopy. That one I might, well, we'll see. Okay, so let's go over to After Effects. So I'm going to take the clip and drop it into After Effects. And I'm going to bring in all of the images that I just grabbed. All these Creative Commons images. It's amazing what you can find on the internet. Yeah, let's do this one. Okay. So we've got a lot of images. I tried to find large ones since they will be most helpful, I guess. However, they're sort of square-shaped, but luckily it doesn't really matter what direction they're facing. So what I'm thinking I'm going to do is rotate the square ones so that they fit a little bit better, rather than trying to blow them way up. Yeah, let's try and do that. So we'll do 90 degrees. That works too. This one actually is square shaped, I think. Okay. We'll scale that up. Position it down. Okay. We'll do the same with this one. This one's actually a little bit smaller, so we will have to scale it. Like so. And then we'll move it down so you get that nice edge. Alright. And then we got this one, which I think is oddly shaped. So we'll rotate that. Right? Is that smaller or bigger? It's about the same, huh? Alright. We'll do that. And then we'll scale that up as well. Oops, come on. There we go. And then, last but not least, this one is quite large. And we'll do that. Okay, we've got some cool images of two-photon microscopy. And now we're going to incorporate these. Let me make sure you can see what I'm seeing. Yeah, good. So let me just get these out of the way and see what she says.
Using a technique called two-photon microscopy, a high-tech kind of microscope that lets two-photon microscopy, a high.
Okay, so she mentions two-photon microscopy and then sort of gives a brief explanation of what it is. I'm going to bring on these images after she says two-photon microscopy.
Two-photon microscopy.
Right about here. Let's really get it off with a bang, though. I want a really nice image so people are like, wow, that's cool. This one's pretty neat. Let me just double check though. I want to make sure that this is two photon microscopy. Z projection, okay. It was taken on a confocal microscope. So it's that actually is not two photon microscopy. It's a different kind of microscopy. Okay, so it's an alternative to two photon microscopy, so we cannot use that image. Alright, that's too bad. That's kind of a cool picture. But that just means we have this alternative. I'm going to zoom out a little bit so I can see the edges. What I want to do with this is sort of have a slight amount of movement. So we're going to, first we got to bring it on to the screen, I guess. Have it zoom in from the side. Add some motion blur to it. Let's see if it lines up properly.
A high-tech kind.
Yeah, that works. So after it stops moving, we're going to have it just ever so slightly sort of move. Slide up. It'll be very subtle, I think, but just makes it a little more dynamic.
A high-tech kind of microscope that lets.
That's not that subtle, but that's okay.
Microscopy. A high-tech kind of microscope that lets. A high-tech kind of microscope that lets researchers get a clearer look.
Okay, so we got a nice subtle movement, but we want to incorporate some of these other pictures too. We're going to copy the same movement like this. Yep, that'll work. I want to position it slightly lower though, because we want that nice edge on top. And turn on the motion blur.
A high-tech kind of microscope that lets researchers get a clearer.
I might zoom this in even a little bit more, just because I really want that to fill up the entire screen, or a lot of the screen. Even if we're losing a little resolution, I think it will be worth it. Yeah, because you can see those blood vessels. Look at that. That's crazy.
A high-tech kind of microscope that lets researchers get a clearer.
And again, we want to have that subtle movement. Oops. So let's have it move to there, but that just means that at the beginning we'll want it to start a little bit farther over here. Okay, let's see what that looks like.
That lets researchers get a clear.
Oop. See how it appeared right off the edge of the screen, right up here? Yeah, we can't have that. Let's move this over. Okay, there we go.
Microscope that lets researchers get a clearer look.
Oh, whoops. That's the other thing. There we go.
That lets researchers get a clearer look at deeper tissue levels.
I'm actually going to switch those.
Researchers get a clearer look at deeper tissue. Researchers get a clearer look at deeper tissue levels.
Cool. Alright, so got that. Once that's gone, this can be cut. And then we have one more. I'm not crazy about this image. It's a little blurry. It's just not the quality that I'm hoping for. So let's see if we can find something a little bit more exciting with 2-photon microscopy. We want a large image. That's not what I clicked on. Sorry, I'm just going to be looking for something here. Give me one moment. Okay, I'm not ignoring you guys, I'm just trying to find the perfect picture, the last picture that we'll need to show off how cool 2-photon microscopy is. So popular. Okay. Well, we're a little thin on options. Ooh, what about this? Oh, that's kind of cool. Alright, we'll do this guy. So we've got a 2-photon microscopy image of a neuron. So we're going to drop that in. Where'd it go? There it is. Boom. We're going to rotate it and scale it up. You can see that in the corner they're missing some pieces right up here. So we're just going to sort of hide those. Make it look real nice. It doesn't need to be that big like that. And just like we did with the other ones, we're going to have it up here. Like so. And then it's gonna just move a little bit like that. Let's see what that looks like.
At deeper tissue levels, they found the CSF.
We kind of did that same movement before. So I might actually have it move down ever so slightly. Oops. Or maybe up. Up might be better. There we go. Let's try that.
At deeper tissue levels, they found the CSF actually flows.
Good stuff. All right, turn on motion blur. Clean this up. Once that's covered up, we no longer need this one.
Using a technique called 2-photon.
of microscope
lets researchers get
a clearer look
at deeper tissue levels. They found the CSF
Okay, so we have sort of finished with the image. We don't need it there anymore. So we're just going to have it sort of fly off.
They found the CSF actually flows
around the blood vessels of the brain. So she's saying that the CSF flows around the blood vessels of the brain, which is sort of a revelation.
Using a technique called two-photon microscopy, a high-tech kind of microscope that lets researchers get a clearer look at deeper tissue levels, they found the CSF actually flows around the blood vessels of the brain.
Okay. We're going to put in the text, though, when she says two-photon microscopy. So let's put that in there. Photon microscopy, and we'll center that, align it center as well, scale it way down, and we'll position it down there, and then have it fly on like you do, using a
technique called two
moon right there.
Technique called two-photon microscopy, a high-tech.
Oh, what happened to it? Oh, it's down here. Let's put this all the way at the top. And we're going to have this run off the screen again. Like so.
Called two-photon microscopy, a high-tech kind of
microscope
that lets researchers get a clear at deeper tissue levels.
The
CSF actually flows around the blood vessels of the brain.
All right, that works. Save that. Give me 1 second. I'm just gonna use the restroom real quick. I'll be back. Wait for me. Oh, I'm gonna need more coffee. back. I got more coffee. I got a snack. We're good to go. Let's get back into it. Let's see if there's any comments. Hello, everybody. Glad you could join. All right. Let's get back into the editing process. A
technique called two-photon microscopy, a high-tech kind of microscope that lets researchers get a clearer look at deeper tissue levels. They found the CSF actually flows around the blood vessels of the brain, using a technique called...
Okay. I'm going to actually go to the source, to the paper that we're using, and see if they have any images. Oh, it looks like they do. We're going to save that image for later on, but it's pretty exciting. Great. We've got two images that seem to show the blood vessels. Images. Okay, there's one. Boom, boom, boom. Here's another. It's not a great image. It's a little blurry. That's okay though. Ooh, there's even a little GIF. Look at that. Holy smokes. Definitely gonna save that. We've got a GIF, folks. We've got a GIF. Alright, cool. Sorry, I'm getting distracted by GIFs. We've got a GIF of this brain rotating that we are definitely going to incorporate later on. But right now, let's just move on to the next part of our Premiere file. So let's bring you back over there. And we're moving right along.
And this flow of CSF seems to be dependent on the astrocytes, and specifically the processes they wrap around the blood vessels of the brain.
Okay. First things first, we're going to have to differentiate this shot from the last one by zooming in.
And this flow of CSF seems to be dependent on the astrocytes, and specifically the processes they...
So we've got astrocytes and then the processes, which is a fancy term for essentially the little dendrite or the little arm that comes off the astrocyte that wraps around the synapse of the neurons. We're going to want to demonstrate that because otherwise people aren't going to understand what she's talking about when she says the processes. Just a little snack. Because we're going to be getting into a little bit of animating. Okay. Well, let's bring that into After Effects. Come and join me.
And this flow of CSF
seems to be dependent on the astrocytes, and specifically the...
CSF seems to be dependent on the astrocytes, and specifically the processes they wrap around the blood vessels of the brain.
Okay, I'm just thinking in my head how I'm going to do this. So I think what we're going to do is we're going to take the, we're going to do a green side.
And this flow of CSF seems to be
dependent on the
So we're going to have the green come in right there. We're going to have Allie's video move over. At the same time. Turn on the motion blur.
dependent on the astrocytes.
And specifically,
This is they wrap around the vessels of the brain. And
Okay.
this
CSF
This flow of CSF seems to depend on the astrocytes. We're going to move it just slightly so that astrocytes can come a little bit later. We've got an astrocyte in here. We're going to drop that in. We're going to position it over. It's going to be nice and centered on this green guy. We'll scale it up like so, and then we'll time it with the other stuff. But we actually want it to come a little bit later. Not too much later, just a little bit.
dependent on the astrocytes.
Good. Motion blur's on there.
Dependent on the astrocytes.
and
Specifically the processes. So we want a blood vessel to come down through, and the astrocyte to wrap around it, kind of. How can we do this easily? Is it the blood vessel or is it the synapse?
Dependent on the astrocytes. And specifically the processes they wrap around the blood vessels of the brain.
Let's hop back over to Premiere real quick. Oh, you guys are already there. No, you're not. Okay. Hop over to Premiere. Let's see what the next few lines are. Get a better idea of where we stand.
When researchers deleted a key astrocyte protein, aquaporin 4, a water transport channel, it had a big effect on the flow of CSF, knocking it down by 70%. Even more interestingly, mice that didn't have aquaporin 4 protein weren't able to clean out amyloid beta protein very well. And since amyloid beta clumps together and plays a big role in Alzheimer's disease, this could have pretty big implications for understanding neurodegenerative disorders. Not long after they published their research, another paper came out that showed the flow of CSF increases when mice are sleeping. And that's because the astrocytes of the brain actually shrink, leaving more space between the brain cells, so more CSF can get into the nooks and crannies of the brain.
Okay. Give me 1 second. I'm going to actually text Allie this question. So here's what we got to do. Oops. What I've got to do first is mess with some stuff here. Give me 1 second. I'm just taking care of some things that I need to do. Okay. We're just going to continue moving forward. I'm just getting caught up because I'm running out of storage on my main drive. That's okay though. So let's go back to After Effects and take a look at that. Don't want to get too distracted. We got to keep moving on this. I'll tell you what, I'm going to move forward. What I'm really waiting on, I guess, why I got caught up is because she says that the processes of the astrocytes wrap around the blood vessels of the brain. And I just want to make sure that she meant to say blood vessels and didn't mean neurons or brain cells. Who knows? But I'm going to go ahead and say that she did mean to say blood vessels, which means we're going to need a blood vessel running straight through the middle here. Blood vessel should be red, huh? Kind of a red like that. And we can include a stroke on it too. We'll make that a nice deep red. Okay, let's do that. Like so. I'll tell you what, we're going to edit it slightly. Make it a little, move it off to the side. Make it a little skinnier. Okay. We're going to hide that for now, because we're going to edit this astrocyte.
Dependent on the astrocytes, and specifically.
So we're going to edit the position on this because, and also the scale, because it's going to move off to the side, get much larger, and then one of its arms is going to stretch out and essentially engulf, sort of wrap around the blood vessel. So we're going to have it scale up. We're going to also rotate it. So let's turn that on. Rotate. Which one do I want to use? Maybe this one right here. We also don't have to see it on screen, I suppose. Yeah, that's true. And then we'll move it off. And we can rotate it. Maybe just slightly. So you see a little bit of it, you know what I mean? But it's not like you're giving away. It's sort of like Alien. You don't want to see the entire Alien for most of the movie, because otherwise you're giving it away. And the blood vessel is going to pop up from out of nowhere. I might actually just have it sort of wipe on. So we'll do a mask on it. Oops. Pre-comp. Oh, you know what? We can do this. Alright, she confirmed that they do wrap around blood vessels as well. That is great. So we're going to mess with the scale. And we're just going to do that. But I want it to scale from the other side. So let's move this right up here, because I want it to sort of come from the top. And then we'll scale it like that. And why not, we'll apply a little effect on it too.
Specifically, the processes.
Okay, let's add some motion blur on that.
Specifically, the processes that.
Alright, so I'm going to have a little dendrite come in, wrap around this blood vessel, and we'll call it a day. In order to do this, I'm just thinking, I'm just going to try and use the same colors as the astrocyte that we've already identified. Okay. There's two ways that I could do this. One would be to start off with the completed, and one to start off with the, from off screen. I think I'm going to start with it being done already. So it'll be sort of like, oops, sort of like this. It's like wrapped around. Like so. So you can see it's kind of like an arm or something. I'm going to have it expand like that. That, because we're also going to have another layer that gives us the three-dimensional look. Oh yeah, look at that. So now you know it's wrapped all the way around. Right, more or less. Looks a little messy up here. Let's correct that. I see. It's not smooth. Smooth move. And same thing for this one. We want to smooth out these lines. That's much nicer. Yeah, I like that. Okay. So now what we have to do is change the path on that. So we're going to put a marker on the path, and I'm just going to move back, and I'm just going to I'll tell you what. First we're gonna move these back. This will come down. Oops. Want to even out any of these harsh lines during the transition period. like so. And then even more here. This will start to come back like that. This will move backwards. Like that. Yep. This will come up. This will come up. This will come back. I'm just sort of getting an idea of like how would this recede over time. I wish that you could just sort of delete keyframes, but unfortunately we would lose all of the data that we're building up. Like that. Then I think I just want to get kind of to a point or like a nub, and then we can move back all of them at the same time. Oops. So it's getting pretty close to a nub status right there. Okay. Let's see, that's good. And then what we're going to do is just select all of these and move them back. And then these will also move back. And alright, I know it's tedious, but we're getting places. You are seeing how the sausage is being made. And now we can really move this stuff. This can really just sort of recede off screen. And one more. Good. All right, the timing is not going to be right, but we can mess with the timing as needed. And then we'll have to fix this guy right here.
Sites and specific sites and specific processes they wrap.
Okay, so we want them to wrap around right when she's talking about wrapping.
The processes they wrap around the blood.
You can see it's a little bit jerky. It's like boop, 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 1, 1, 1, something, something, something. So we want to make it look a little more natural. In order to do that, we're going to want to just sort of move the arm and stuff when everything else is moving. So you can see from here to here, there is no change right there. So we're going to change it. Let's see, we're going to have come on now. What are you doing? There we go. So maybe it'll go from like a little bit skinnier. Just so it looks like there's some movement, because otherwise it's like, ooh, nothing's happening. So it sort of gets skinnier and then evens out a lot more, like it's stretching out on the end of it. And then this will not do. Okay, it looks all frail. Okay, let's mess with this, huh? We're going to move that. Move this. Move this. Move this. Just because we're getting these weird edges and I really do not like them. So we're gonna, I should have done this from the start, but you live and learn. Alright. It's a little bit better. Okay, and then the same thing here, we're going to move the process back. This should move way back. Move this back. Move this back. Bear with me, folks. Bear with me. Move this. And that one's fine. This can move. This can move. And that one can move. Alright, let's see if that looks a little bit better. It looks like an alien claw right there, so we're just gonna smooth that out. The claw. Alright, that's gonna go back there. That's gonna go back there. That's gonna go there. Cool. That looks a little bit nicer. See that movement where it's like boom, like a little bounce? Let's try and put some easy ease on all this. I don't know what that will do, but let's find out.
The processes they wrap around the blood vessels.
Well, it's sort of weird looking, but could be way worse.
The processes they wrap around the blood vessels.
Sort of like slows down and then. Actually, don't mind if it stops there. These two don't need to be easy-ease. Let's try that.
The processes they wrap around the blood vessel. The processes they wrap around the blood. The processes they wrap around the blood.
This one also doesn't need to be easy-ease. Let's try that.
Processes they wrap around the blood vessels.
Okay. From here to here, I think it's also just the timing, you know, like. You know what? Let's do this. Let's eliminate this keyframe.
The processes they wrap around. The processes they wrap around.
Let's try this.
The processes they wrap
around the blood.
That's not bad.
The processes they wrap around the blood vessels. The processes they wrap around the blood vessels.
Yeah, that's not bad. Okay. All right, with this guy, we're gonna edit him in. So that's the end. The end of the path. Nice. We just got a little prize. So we won this video contest about well, it was for the Brain Facts Awards video. And Allie is at the Society for Neuroscience conference, and we won a little prize for it. We won first place in the video contest, which is kind of exciting. So she just went to a little ceremony where she got a plaque and everything like that, so that's pretty cool. All right. Willem, I hear your commentary about blood vessels being blue rather than red. I'm gonna say that for the purposes of style, I'm gonna keep it red. But I do appreciate the feedback. I think I'm gonna keep it red, just because I think most people would understand that, like, when they think of blood vessels, that's what they would think of. Just a stylistic thing, and but I do appreciate sort of the accuracy component of that. If that makes sense. Okay. So from here, it needs to disappear, essentially. So it's going to go from there. We'll have it all start here, up at the top. And we're going to just make this really small, because I don't want it expanding out yet. And then we're actually going to have it transform, because I want it to be 0 before this. 0 opacity. And then it will come on the scene.
Wrap around the blood vessels of the... Wrap around the blood vessels.
I don't want it to line up exactly with the other one. And I also appreciate the easy ease. So let's do that.
Wrap around the blood vessels. Wrap around the blood vessels. Wrap around the blood vessels.
Let's try that.
They wrap around the blood vessels of the brain. They wrap around the blood. They wrap around the blood vessels of the brain.
Alright, let's see what that looks like.
The processes is they wrap around the blood vessels of the brain. And
it's not horrible. It could be much worse. I'll tell you what though. On this one, I'm gonna have a sharp edge, because that's what it should have. Good. And same thing for this one. Sharp edge right there. And that's a sharp edge. Okay, good. That way it actually looks like it's wrapping around rather than
wrap around
bulging.
The blood vessels of the brain. They wrap around the blood vessels of the brain. Wrap around the blood vessels of the brain. And
what if I deleted this one? Would that be horrible?
they wrap around the blood vessels of the brain.
Yeah. I actually like it the other way.
The processes they
Is they wrap around the blood
vessels of the brain. Specifically, the processes that
They wrap around the
vessels of
they wrap around the blood vessels of the brain. Specifically, the processes they wrap around the blood vessels of the brain.
Okay, sorry, I'm like getting caught up in my own mind. Sometimes I forget to talk. So I think that's okay. You can see this guy move right there. So let's go to the astrocyte. And it looks like he had another position point there for whatever reason. And that should help. Now he's not moving around. Okay, good. Well, I'll tell you what, I think that is good enough for our purposes.
And specifically, the processes they wrap around the blood vessels of the brain.
I sort of want it to look like this sharp edge here, though. So let's edit this to look nice and sharp. Okay. There, let's try that out.
Specifically, the processes they
So part of the problem is this. Oops. No.
the processes they around the blood vessels of the brain.
Well, good enough, I think. All right.
The processes they wrap around the blood vessels of the brain. And
it's a little chunky, you know what I mean? Like, chunks. Chunks of stuff right there. But we can smooth that out ever so slightly. Make it look less chunky. Let's check that out.
Typically, the processes they wrap around the blood
That's a little bit better. Okay, good. Whew, I got caught up there, but we're gonna move on to the next thing. So let's hop back to Premiere.
When researchers deleted a key astrocyte protein, aquaporin-4, a water transport channel, it had a big effect on the flow of CSF, knocking it down by 70%. Even
Okay, aquaporin-4.
Researchers deleted a key astrocyte protein, aquaporin-4, a water transport channel. It had a big effect on the flow of CSF, knocking it down by 70%.
All right, so that's some information that we'll want. Aquaporin-4 and then 70%. Let's bring that into After Effects. we're going to do another green side, this time from the other end. Oops. There we go. Oh, sorry. Let me bring it back over. Back over to After Effects.
When researchers deleted a key.
So let's just start Alley off to the side and zoomed in. Like so.
Key astrocyte protein, aquaporin 4, a water.
And then we'll throw in some text. Aquaporin 4. I think that's how you spell it. Let's take a look. Aquaporin 4. Yep, okay. Aquaporin 4.
Aquaporin 4, a water transport channel.
Big effect on CFS.
Aquaporin 4, a water transport channel. It had a big effect on the flow of CSF, knocking it down by 70%.
Okay. It's really just that and 70%. I think I have a little effect that I can use here. Yeah. Okay. All right. So we're gonna animate this. We're gonna scale this way up. Position it lower and a little more centered.
Knocking it down.
Oops.
Knocking it down by.
And then we're going to start it off at 0. Nope, nope, nope. Oh, I get it. would like for it to start later. Let's open up this effect. There we go.
It down by 70%.
Sorry, I was trying to learn how to use this again.
Knocking it down by 70%. Knocking it down by 7. Knocking it down by 70%. When researchers knocking it down by 70%.
Okay. So we've got Aquaporin 4, we've got the 70%. Aquaporin 4 is not yet animated, so let's do that real quick. Like so.
When researchers deleted a key astrocyte protein, Aquaporin 4, a water protein, Aquaporin 4, a water transport channel, it had a big channel. It had a
down by 70%.
When researchers deleted a key astrocyte protein, Aquaporin 4, a water transport channel, it had a big effect on the flow of CSF, knocking it down by 70%.
All right. Not bad. I don't know. There's not really that much more that I feel like putting in there. So I think I'm just going to leave it at that. Let's make sure that we're saving. Well, let's hop back over to Premiere and keep moving.
Even more interestingly, mice that didn't have Aquaporin 4 protein weren't able to clean out amyloid beta protein very well. And since amyloid beta clumps together and plays a big role in Alzheimer's disease, this could have pretty big implications for understanding neurodegenerative disorders. Even more interestingly, mice that didn't have aquaporin 4 protein weren't able to clean out amyloid beta protein very well. And since amyloid beta clumps together and plays a big role in Alzheimer's disease, this could have pretty big implications for understanding neurodegenerative disorders.
I am not going to put any animating in that. But we are going to zoom in.
Mice that didn't have aquaporin 4 protein weren't able to clean out amyloid beta protein very well. And since amyloid beta clumps together and plays a big role in Alzheimer's disease, this could have pretty big implications for understanding neurodegenerative disorders.
Good.
Not long after they published their research, another paper came out that showed the flow of CSF increases when mice are sleeping. And that's because the astrocytes of the brain actually shrink, leaving more space between the brain cells.
Okay, let's try it. Let's look over that again.
Not long after they published their research, another paper came out that showed the flow of CSF increases when mice are sleeping. And that's because the astrocytes of the brain actually shrink, leaving more space between the brain cells, so more CSF can get into the nooks and crannies of the brain.
All right, we're definitely going to put some animation on that. Let's open that up in After Effects. We're going to bring in the old animation that we had before, the one that we created of the astrocyte process. But this time we're going to do a little bit of some text beforehand. However, just to start off, I'll bring in that green solid.
Not long after they published their research.
Okay. Scale that up. Okay.
Research. Another paper came out.
All right, we're just going to do some simple text. We're going to make that sleep text a little bit larger. Okay, scale it down, position it over. What else does she say after this?
And that's because the
Alright, we don't really have much else before we get to the next part, so I'm just going to position this centrally. Maybe a little bit low, and then we're going to bring in an arrow. Bring in this guy, and we're going to scale him a little differently. Rotate it 90 degrees. shrink them down. Position it nice and centered. There we go. And we'll change the color. Change it to, I don't know, what are we feeling? Blue's not bad. Purple's not bad. We didn't really represent CSF in any particular manner before. Let's do purple. Okay. That's nice. So both of these we need to animate. Oops.
Research. Another paper came out
That showed the flow
of CSF in
Okay.
CSF increases when CSF increases when mice are sleeping.
Oops.
CSF increases when mice are sleeping. CSF increases research.
No, we'll try to show that paper.
Another paper came out that showed the flow of CSF increases when mice are sleeping. And that's because
Okay. So we've got that. Let's turn on the motion blur. I want to find this other paper if possible.
Paper came out that showed the flow of CSF increase.
Ooh, now it's just me. So I can relax a little bit. Okay. I am not doing a great job of communicating while I'm going along. I'm getting zoned in on stuff, so I will try and be a little more entertaining as I'm talking. So what we're doing now is just trying to demonstrate what she's saying. She said that there was another paper.
Another paper came out that showed the flow of CSF.
That showed that the flow of CSF increased. So what I want to do is I want to try and find that paper. Let's see. It's one of these resources that we've got. I have too many tabs open. Nope. That's not it. One moment. Things are just running a little slow. Okay. That's not the article. No. Let's try this article. Too many articles. Gotta find... this might be it. Nope. Okay, I think I found the article. Now I'm just going to try and figure out how exactly to how to bring it in. Here's a PDF. Perfect. I just want the first picture, first page. Okay. So we're still in After Effects. What I'm going to do is I'm going to drop this PDF. I've never done that before, but I'm going to drop a PDF into our comp. Huh. That's interesting. Look at how that works. Okay, well, I'm going to try and do this. Let's try this. Let's try saving it. Alright, come back to After Effects here. And I saved it as a JPEG instead of PDF, and that seems to have worked. Let's scale that down and position it over. And we'll oh, come on. We'll have that fly on. Let me just exit out of some stuff because it seems like my computer's running slowly as a result of having all of this stuff open. Okay, great. So we're back at it. Oops. There we go. I'm not going to lie to you guys. This is a long stream, and it's going to just keep going and going. So we're back here in After Effects. Are you with me in After Effects? You are. Okay, good.
Their research. Another paper came out that showed the
flow of CSF in.
So we only need the paper on there for a short period of time. We're going to have it fly off before the arrow comes on. Let's make sure that we got motion blur on.
Another paper came out that showed.
And let's make sure that we add drop shadow. There we go.
Another paper came out that showed
The flow of CSF in.
of CSF increases when mice are
Sleeping. And that.
when mice are sleeping, and that.
So when she says that, we want those items to fly off the screen. No, we don't want that.
And that's because.
Oops.
And that's because. And that's because. And that's because the astrocytes of the brain actually shrink.
Okay. Now what we're going to do is we're going to bring in that old animation that we did right here. While we're not terribly interested in the beginning part, we are interested in the end part. So here's the whole growing process. We want just the end. So we're going to do that. Okay, I'm going to take a quick pause. I'll be right back, folks. Alright, sorry about that, folks. Just had a little call that I was taking care of. Let's hop back in and see where we're at with our After Effects comp. Thank you to the one person who stuck around while I was gone. You're a true friend. Okay. So we've imported the process. I think what I'm going to do is when I actually have this move and like appear on the screen, I'm going to pre-compose it so that it's easier to mess around with. But let's see how this all fits in with everything right now.
That's because the astrocytes
Okay, so she says they actually shrink. Actually. So we'll stop right there. And we're going to bring up the path on this guy. Actually shrink, leaving room for the CSF to go in between. So we're going to hop in here and oops. And we'll give it some nice room like that. So you can see that there's some space. Around these processes. And we should actually see it shrink rather than just move, right? Okay, we want to make this transition smoother, like so. Make those lines not so jagged. And we'll move this guy up too. And move this guy up. There we go. And this one should also move. Alright, we'll open up that, open up the shape, open up the path. We will put a keyframe on that path and have this guy move as well. Moves right up. Maybe even moves in a little bit. Okay, let's see what that looks like.
actually shrink, leaving more space.
Okay, we run into a problem, which is it no longer looks realistic when that moves. Let's do this. Add that. This will remain against that wall. Like so. So it still looks like it wraps around. This can come out a little bit more. This can come down. This can also come down. I don't know why I haven't moved that one. And then we'll do the same for this guy. Oops. We'll move this up. Like so. This up like so. And move back down here. Move this one up like so. And I think we're in a good spot. Let's try that out.
Brain actually shrink, leaving
more.
Actually shrink.
Let's have the arms shrink as well. There we go.
The astrocytes of the brain actually shrink, leaving
More
I could like try and show CSF going in between, but it's colorless, and I just don't think the payoff would be that good. I don't know. Maybe I should do it. Maybe I should do it. Nope, we're not gonna do it.
CSF can get into the nooks and
Alright, let's see that.
astrocytes of the brain actually shrink, leaving more space between the brain cells, so more CSF can get into the nooks and crannies of the brain.
Okay, I think that's fine. Let's jump back over to Premiere. And let's take a look at that. And we'll move on to the next clip.
It's sort of like moving the couch when you're vacuuming. So it could be that...
Okay, that's just going to be a close-up. Boom, boom. Easy peasy.
It's sort of like moving the couch when you're vacuuming. So it could be that one of the reasons sleep is so important for our health is because it lets our brains go into their deep cleaning mode, cleaning out all of the junk between our cells so we wake up nice and refreshed.
I like that. I don't think it needs any animation. We're just going to bring it in a little bit closer. Yeah, that looks nice.
Could be that one of the reasons sleep is so important for our health is because it lets our brains go into their deep cleaning mode, cleaning out all of the junk between our cells so we wake up nice and refreshed.
Good. All right. If you're joining and you have something to say, please feel free to leave a comment. I will be reading them in the chat. We're just going through piece by piece, editing the video that's going to be coming out tomorrow. We've made quite a bit of progress in a short amount of time. So as you can see, there's a lot of animations already in the video because we need to demonstrate exactly what we're talking about, in particular the information about the lymph nodes, not the lymphatic system, but actually the lymph nodes, which isn't even in the focus, took up a decent amount of time in terms of animating. But now we're past that point. I will not be really animating the lymphatic system, or I won't have to come up with that. Since it is something that's new, there's no real... I'd have to create it from scratch, and that's and it wouldn't even look great, I guess. It wouldn't necessarily be accurate. It'd be hard to demonstrate in an image. So rather than doing that, I'm just going to be grabbing from the article, from the paper that this discovery was made in, because they have images of the lymphatic system in there. So let's keep moving and see what else we can do. See what other editing is needed at this point.
All of this seems like pretty good evidence that our CSF is acting kind of like the lymphatic system of the brain, but not connected to the rest of the body.
Okay, we will actually edit this in After Effects because I want some continuity with some of the imagery that we were using before. We showed the lymphatic system running throughout the entire system, running throughout the entire body. I would like to carry that into, so we have all these like blue veins, more or less, right? The veins that run throughout and then goes into the lymph nodes and gets destroyed. So what I would like to do is sort of copy that imagery of blue veins running throughout the brain, even though that's not really how it works. But let me find the brain that we were using before. Blah, 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 blah. I think it was here. Yes. Okay, so there's a brain somewhere. I think it's this guy. We're going to paste that brain in here. Where is it? There it is. Okay. Sort of like.
All of this seems like pretty good evidence. Evidence that our CSF is acting kind of like the lymphatic.
So we're going to take the brain, we're going to scale it up quite a bit. Let's just make sure that, yeah, they're both rasterized. Great. Oh, I'm sorry, I did not switch you over. Let's switch you back over to After Effects here. So I have the brain. We're going to scale it quite a bit. Bring it over. And Allie is going to have to move, but also scale. That'll work. So one thing that we could do that might be pretty easy is just to change these lines blue to make it essentially match the color here that we see. It's like we've already got a system in place. Look at that. All right. Yeah, I think that's what we're going to do. So here we go. We're going to duplicate this. Actually, before we do that, let's just line things up.
Kind of like the lymphatic system of the brain.
So she says brain right there. So we're going to duplicate this. We're going to zoom in on this brain, and I want to maintain the pink outline there, but then have it sort of blue on the inside. So here's what we're going to do. We're going to come down like that and do one of these, one of these, one of these. Okay. Change to color. We're going to choose that nice red, and we're going to change it to this blue. And hue, lightness, and saturation. We're going to take down this. Softness way up. Way down. No, we'll turn way up. That doesn't make a difference. For the lightness, we'll do 1.5. 3. Nope, too much. 2. 2 is better. You can see that there's still some crud around the edges. Not ideal, but we can handle it. Yeah, it's not perfect. Okay, and then we're going to duplicate this again. We're going to do the same thing that we did last time. Oops. Which is create a nice mask. Boom, boom. Boom, boom, boom. Boom, boom, boom. There we go. Remove the shadow. And we're just going to copy from the one above. There you go. So there's the lymphatic system of the brain, kind of. We might even add in a few more squigglies just for fun. And we want this to fade in. Okay. Let's see what that looks like.
Lymphatic system of the brain, but system of the brain.
Brain. Let's just move these back. But not connected to the rest of the body.
The brain, but not connected to the rest of the body.
And again, we're going to copy that red X that we had before. Oops, too far, too far. There we are. Copy that X. Bring it all the way over. We'll have it appear just right there at the end. Scale it up. Position it down by the brain stem, since ostensibly that leads to the rest of the body. We'll put a little sound effect on that later on.
The body. All of the body.
You can have it right there.
Rest of the body. All of the rest of the body. All.
Okay, we don't need this lymphatic system.
Like the lymphatic system of the brain, but like the lymphatic system of the brain, but not connected to the rest of the body. All of this seems like pretty good evidence that our CSF is acting kind of like the lymphatic system of the brain, but not connected to the rest of the body. All of this seems not connected to the brain, but not.
I changed my mind. We're going to put it on not.
But not connected to the rest of the body. Brain, but not connected to the rest of the body.
Excuse me. All right. Great. So we've completed more or less the brain coming into play. We have demonstrated that it looks like this is the lymphatic system of the brain, but with the blue. Let's then move on to the next part because I feel pretty good about that. So let's go back back to Premiere. Here we are. And let's see what she says next.
But recently, a new paper came out to confirm what some scientists have thought for years. The brain does have lymph vessels. We just hadn't seen them yet.
All right. I think we're going to keep it simple with this. Let's zoom in ever so slightly. Okay, that's fine.
Recently, a new paper came out to confirm what some scientists have thought for years. The brain does have lymph vessels. We just hadn't seen them yet. In 2015...
Okay, so we really want to emphasize that does, right? The brain does have lymph vessels. So let's come on over back to After Effects. The brain does have lymph vessels. One of the ways that I can do that, because it's sort of an important point of the video, we really want to emphasize that line. The brain does have lymph vessels. The brain does have lymph vessels. What you can do is just take your text and paste it right over the front. So let's put a drop shadow on there. In order to make this work, you really have to mess around with the text in terms of distance and whatnot. So like if you take this and you expand it out a little bit, and then does is going to be really large because it has to fill up a bit of space. Woo. The rest of these will have to go down in size. This should also come down, even though and this can also come down. What's the size on that? 510? 510. What if we scale it down? And we scale this up slightly. I'm sort of messing around. This is a bit of a predicament because the words are pretty short, but we want to emphasize it. All right. More or less. So the does really sticks out there right now, which is good. That's what we want. And then what I'll do is I'll just have the words come on as she says them. That's all there really is to it. And then we put some sound effects on top of it. So let's do this. The brain does have lymph vessels. And we'll just start separating them out. We'll just do this all first. Oops. Oh, this is going to be a little complicated. what I'm doing is just separating all of this out. All of these words, so that they can appear independently as she's saying them. All right, now we've got all of them, and now what I'm going to do is just place them one by one. So vessels, it doesn't have to be perfect because it just has to be approximately the correct position. So we're going to delete that underneath part. Okay. Perfect. There we go. So now we just want to find the part where she says the actual line.
But recently, a new paper came out. Some scientists have
Okay. So here's what we're going to do. The
brain does have lymph.
Lymph vessels. Alright, let's see if that lines up more or less.
The brain does have lymph vessels. The brain does. The brain does. The brain does have lymph vessels. The brain does have lymph vessels.
I don't know if I like it just sort of appearing or if I want it to animate on. Any opinions on your guys' side? Feel free to hit me up in the chat. Yeah, I'm sort of on the edge about whether or not I like it just appearing or if I want it to.
The brain does have lymph vessels. The brain does have lymph vessels. The brain does have lymph vessels. The brain does have lymph vessels.
I'm really on the edge with that. What did I just do?
Have lymph vessels. We just
Alright, here's what we're going to do. So what I'm doing, I'm going to animate it. If I don't like it, then I can always go back and, you know, change it back to how it was before. But I think this is going to be the right move. Just based on sort of my feel for how it looks. It was not working for me before. Just having it sort of appear out of nothing, it felt too sudden. I know that we're trying to emphasize it, but I think we can do the same thing in this way. Let's find out.
The brain does have lymph vessels. The brain does have lymph vessels.
Okay, that's good. We just need to time it right. So it needs to be up there. So we're going to expand this out for all of them. And then all of these are going to shift. Right there. Let's see if that works.
The brain does have lymph vessels. The brain does have lymph vesses.
Yeah, that works. Let's just turn on the motion blur.
The brain does. The brain does have lymph vessels.
Yeah, that's pretty good.
We just hadn't seen them yet. But
okay, I like that. I like that a lot. All right, that works. Good. Well, let's switch back to Premiere then and see what the next clip will be that needs some animating.
In 2015, a group at the University of Virginia were trying to better understand how the brain's immune system works by studying how it moves immune cells around.
What time is it? All right, it is almost 1:15 here. I tell you what, I'm going to take a short break. I got to make some calls. I got to eat lunch. I just have a few small things that I have to take care of. So we're going to take a quick break. I'm going to take out the garbage, eat lunch, make some calls. I'll be back, let's say less than an hour. I think that's pretty reasonable. But thanks for watching and following along. I'll be back shortly and we'll pick up right where we left off in this episode about the glymphatic system. No, stop.